These always look messy to people at first, but I'll walk you through it. Once you understand the language of it, it's like a lot of things in math. Once you understand the language, it doesn't look so daunting to you anymore. So you're right, I do. I am, yeah, I am. Great. Thank you, though, for reminding me. Always worth checking on that. So what this is, it's a function that looks like one function for part of it, and then we've attached another looking function, different looking function for another piece, and another one for that. So it's kind of a chimera. You guys know what chimera is? It's a mythical Greek creature with the head of a lion and the tail of a snake, and it's got wings, and it's a bunch of, it's like the Frankenstein's monster of the Greek monster world. So that's what this is going to be. It's a whole bunch of little pieces of functions that we're going to cut up and sew together and create some new weird looking thing out of it. And we know all the pieces. It's just a matter of graphing them. I won't typically do this in two separate graphs. I would normally do this on a single graph. I would do it in pencil. I would do my scratch graph, my rough sketch, very lightly in pencil, and then come back and darken in and erase. But that's kind of hard to see in your notes when you do that, so that's why I have two separate graphs here, so that you can sort of have an example of what it looks like before you erase and what it looks like afterwards. So I'm going to start off with I'm going to use a pencil on this, and I'm going to graph each part of this. So when I look at this, I can see there are three distinct parts to this. Our first part is this piece right here, and so I am going to graph the graph y equals x squared. And I'm just going to do this lightly on my scratch work. Again, if I were doing this, I wouldn't make two separate versions of this graph. I would just do it lightly in pencil. When you do these in your assignment, I do expect them to be quality graphs, meaning on graph paper. And if you don't have graph paper, see me and I will get you some that you can use. You can just do the rest of your assignment on a piece of paper and put a couple graphs on the graph paper and make a note on your assignment that those were on separate paper. All right, so there's our first piece. That's y equals x squared. That's not hard, right? You guys know how to graph y equals x squared. All right. My second piece is right here. It is y equals 1. You see how I'm just throwing a y equals in front of each of those things? Because it's got a y equals in front of all of them right here. So y equals 1, can you guys know what the graph of y equals 1 looks like? It's a horizontal line, cuts through the y-axis at 1. All right, there's my second piece. And then my third piece is y equals x plus 2. And my Algebra 1 students in about a month and a half will be super confident graphing that. It's got a y-intercept of 2 and a slope of 1 over 1, so go ahead and sketch that graph. So that's all three of those graphs completely graphed all at once. Now we're not going to keep the entirety of any of those three graphs. We're going to kind of chop off just the pieces that we want, and those will appear in our final graph. Okay. So let's start with y equals x squared. That's our parabola here. What part do we want to keep? I only want to keep the part where the x values are less than 1. X value is less than 1. So I'm going to cover up the part that I don't want to keep. I just want to keep that much of it. Focus on this parabola here. That's the only part that I want to keep. So I want to keep this portion of it. If you don't have colors here, you could just kind of darken that part in with your pencil. Okay, and I'm going to draw a little dashed line here at 1. So in my final graph, I will have a portion of a parabola over here. It ends at 1, so I should probably put an endpoint here. Open dot or closed dot for my endpoint? Open dot or closed point for my endpoint? Open dot, because x is less than 1, not x less than or equal to, x is less than 1, so that'd be open dot. Hooray. All right. So that's what I'm keeping from my parabola. What am I keeping from my horizontal line? That's this one right here. It says we're only going to keep the portion of that graph between 1 and 2. That's not very much of it. So for my horizontal line, I'm only keeping this portion between 1 and 2. Let's put some endpoints at that. It looks like at 1, it's going to be a closed dot. This is an interesting situation. I have a closed dot that's filling in an open dot. They happen to be right on top of each other. That's not always the case, but if that ever happens, the one just fills in the other. And it looks like you would have an open dot at 2. So in my final graph, we really don't need a dot there at all because it's been closed in. It's part of the same thing. We just need to make sure that they connect nicely. We doing all right? Are these looking a little less daunting now that you've seen kind of how they fit together? Our final graph was y equals x plus 2. That's this portion. What part of that are we going to keep? We're going to keep the portion where x is greater than or equal to 2. So again, focus on your x coordinates. We're only keeping this portion of it over here because this is where x is equal to 2. That's where x is greater than 2. So we're just keeping this and greater than or equal to, so that'll be a closed dot there. So my final piecewise defined graph is going to look something like this. And that's it. So we're just basically drawing some very simple graphs, but keeping certain portions of them. And then if I were doing this on an actual assignment, then I would come back and erase all of the kind of scratch work that I did for the other pieces. I want to make sure we're comfortable evaluating these really quickly. If I ever had a piecewise defined graph and I were asked to find, for example, f of negative 4. So this is kind of down lower on the page, but just so that we can see it next to the equation. You guys know that in algebra, when I say find f of negative 4, that means take negative 4 and plug it into the equation and give me a y value, right? The question with this is, which of these 3 equations should we plug it into? The first one, the second one, or the third one? What do you think? I love that you're linking it to the graph, but let's pause and imagine we don't have the graph in front of us right now. I'm going to check against the graph here in a moment, but that's awesome that you are making that connection. How could you know that it goes? You're right. How could you know that it goes with the first one based strictly off of the equation? Yeah. So I would look at this 4 and I would ask myself, which of these 3 restricted areas does it fall under? And negative 4 does fall under this one. It's less than 1. Negative 4 is not between 1 and 2. It doesn't fall into this region. And it's not greater than 2. It's less than 1. So I would plug it into the first one. I would put negative 4 in here. I would square it, and I would get a value of 16. So f of negative 4 is 16. Now, if I had a nice graph of it, I could check and make sure that the point negative 4 comma 16 was on that graph, and if it was, then that would validate the algebraic work that I did just a second ago. Looking at our graph, can you imagine that negative 4 comma 16 would be on the graph? Seems like it could potentially be there. Let's do one more of these. What if I asked you to find f of 1.5? f of 1.5. What region would we be looking at this time? The second region here, so we would plug 1.5 into this in place of x. Oh, there's no x's to plug in there, it's just 1. F of 1.5 would be 1. Can you look at your graph and tell me, is the point 1.5 comma 1 on our graph? Yeah. It is, so that validates that that's correct. All right, thank you all for your attention today. We'll go over any questions you have from this or from the parent functions next class. The next assignment's on Canvas. It does not have solutions attached to it, but I fully expect that you're checking your answers in the back of the textbook as you go. All odd numbered questions, answers are in the back of the textbook.